Welcome to NCERT. In this video, we are going to learn about the images formed by a concave mirror using ray tracing. For this, we need to keep 4 rules in our mind. Rule number 1. If the incident ray is parallel to the principal axis, as you can see in the given figure, after reflection, it will pass through the principle of focus. If we draw a tangent at the point of incidence, the center of the curvature is perpendicular to it, making the angle of incidence equals to the angle of reflection, and proving that spherical mirror follows the rule of reflection of light. Rule number 2. If a ray is passing through the principle of focus, after reflection will become parallel to the principal axis. This rule is the exact opposite of rule number 1 because light follows exactly the same path if its direction of travel is reversed, and we call it as the principle of reversibility of light. Rule number 3. If a ray is passing through the center of curvature, after reflection it will pass along the same path. This is because the ray is perpendicular to the mirror. As per the law of reflection, angle of incidence is equals to angle of reflection. So, it will be reflected on the same path at an angle of 90 degrees. Rule number 4. If a ray is incident obliquely to the principal axis towards the pole, will be reflected obliquely. Here, the principal axis acts as a perpendicular at the pole, making angle of incidence equal to the angle of reflection. Now, we are aware about all the rules of image formation by a concave mirror. So, let's move forward with ray tracing. We use ray tracing for locating the image geometrically. As numerous light rays fall on the mirror, we require any 2 incident rays to find the intersection of reflected rays. So, we can choose any 2 rules out of 4. For tracing a perfect image, it's very important to draw the ray diagram perfectly. For that, follow few simple steps. Step number 1. Draw a straight line and take its midpoint and mark it as center of curvature, that is C. Now, mark its another end as pole. Now, you will get a radius of curvature. Yes, you're right. CP is your radius of curvature. Now, next step, divide it into 2 equal halves and mark the midpoint as the principle of focus. Remember, F has to be in the exact middle position. Now, use your protractor to draw your mirror. Remember, its aperture should be smaller than the radius of curvature. Now you're good to go for tracing the images of a concave mirror. Condition number 1. If the object is placed at the infinity. The best example for such object is sun. In this case, all the incident rays become parallel to the principal axis, and the image is formed by the convergence of reflected rays at the focus. The image is highly diminished or point-sized. It's real and inverted. Condition number 2. If object is placed beyond the center of curvature. Here we will apply rule number 1 for ray 1, which will pass along the principal axis and reflect it through the focus. For second ray, we will pass through the center of curvature and reflect it back in the same path. Rays will intersect between the center of curvature and principle of focus. So, image will be formed here. It will be diminished, real and inverted. Condition number 3. If object is placed at the center of curvature. Here we will apply rule number 1 for ray 1, which will pass along the principal axis and through the principle of focus after reflection. Second ray will follow the rule of reversibility or rule 2. The image formed at the center of curvature or C is of same size but inverted. It is a real image and it is a product of actual intersection of the reflected rays. What do you observe in the given condition? Yes, we follow the rule 1 and 3 and the intersection of rays produce the image beyond the center of curvature, which seems enlarged, real and inverted. If object is placed at the principle of focus, then the reflected rays don't seem to intersect each other, rather become almost parallel, but they do so if extended to the infinity. Can you imagine what would the image look like? Yes, it will be highly enlarged, real and inverted. Condition number 6. If object is placed between principle of focus and pole. In this condition, we will apply rule number 3 for ray 1, which moves through the center of curvature and reflected through the same point. For ray number 2, we will apply rule number 4. When ray 2 will be oblique to the pole, it will reflect it obliquely at the same angle. But we cannot observe any intersection there. So, we will expand the reflected rays behind the mirror and their intersection will form the image. Such image is enlarged and erect. As there is no real intersection, so the image formed will be virtual. Hope you understood the topic properly. For more videos like this, stay tuned to my channel and don't forget to like, share and subscribe. Thank you.